Hello everybody, my name is Morgan Lytle, and this is my alarm clock embedded system video. What I've made is an alarm clock embedded system where software is programmed with Atmel Studio and is executed on this Atmel ATmega 1284 microcontroller. So basically what it does is it displays the current time on this LCD screen, and using these buttons the user can set the time, and they can also set a time for the alarm to go off. The first thing I'll do is set the time. Right now it's 12:08 p.m. So I'll press this time change button right here and use this button to increment the hour, and I can use this button to decrement the hour. So I'll go up to 12 p.m. and I'll press the time change button again, and now I'll be able to change the minute using the same two buttons. So it's 12:08. By this time it's closer to 12:09. So I'll press it again, and the current time will be set. These two buttons will be deactivated until I change either the time or the alarm time. So now I'll change the alarm time by pressing this button. Press it again to change the minute. Let's make it 12:10 or 12:10, I mean. Press it again, and these are all the songs that are pre-stored on the system. These songs are user customizable songs which can be programmed in Atmel Studios. All you need to do to add a new song is to fill two arrays. The first of the arrays holds the order of the notes in the song. The second array holds the duration of those notes. And I'll explain that a little bit more after this. So the 12:10, the alarm is going off. And each LED blinks individually and consecutively to each changing note in the alarm song. Notice it repeats until I disarm it or snooze it. I can choose to snooze it by pressing this button. If I press that button, then 5 minutes later, the alarm will go off just as it's doing right now. So I'll press this button to disarm it. The alarm is off, and the system is ready to be used again. And notice during this whole time it was keeping time, as it always does. So the song, like I said, the song is programmed using two different arrays, one of which holds the order of notes and the other holds the value of notes. The user-defined array that holds the order of notes corresponds to another pre-coded, pre-filled array that is stored in the system, which holds the frequencies for all the notes that are usable by the PWM. So integer values will be stored in the user-defined array, and that will be the index of the floating point frequencies stored in the pre-filled array. So those frequencies will be output through the PWM pin, and will come out the buzzer, and the song will be played. So as far as the other hardware on this system, I'm just using this Atmel interface which came with the controller as an interface between the computer and the controller. That's how I download the software. These wires are where the code is transmitted to the controller. All of these are not used during the normal operation of the system. So once you have the software downloaded, I could just remove all of this. These wires correspond to the connection between the LCD and the controller. I'm using the C pins on the controller to connect the LCD screen. And this is just a standard potentiometer, which I can use to control the brightness of the screen. Once you have the the brightness that you like. That can just be replaced with a resistor if you feel like it. And as far as the resistances for the LEDs, I'm using 330 ohm resistors, and that is just to prevent too much power from being sent to the LEDs. And as far as the power supply, I'm using this one right here, which allows me to connect to a conventional household outlet or USB. As far as voltage requirements, you need 5 volts to power the system. And that's basically it for this video. If you'd like to try it, let me know how it goes. If you have any questions, feel free to ask in the comments. And thank you for watching.